Okay, everyone. Hi, and thank you for joining. Hi, and thank you for joining me in this webinar. I'm going to be talking today about RavenDB and serverless computing. Now, this is an interesting statement because what is serverless computing? We are all used to, oh, there is something called a server where my code is running. What happens if you don't have a server? And this is the concept behind serverless, and there are many specific implementations of that. Amazon Lambda, Azure Function, Cloudflare Workers, Google Cloud has something called also functions. They didn't want to invent their own terminology for that. You can run it on-premise using OpenWhisk or Kubeless and a whole bunch of things. But the underlying logic is very simple. I don't want to run a machine. I want to write code, and that code to run in as minimum amount of stuff as possible. I don't want to think about it. I don't want to just make that code run. Now, it has to run because of something. So the idea here is that there is some triggering event, HTTP request, timer, something that invoke your code. Now, you don't control the invocation. You don't control how many instances you're running. You don't control if anything. You just say, here, I got some data, I'm getting some data out, and I'm done. And that is a really interesting model for how you're able to operate. Because it means that on one hand, you lose a lot of control. On the other hand, you lose a lot of responsibility as well. For example, under the serverless or Lambda model, there is one invocation of your code at any given point in time. What happens if I have multiple concurrent requests? Well, that's not a problem. We would still have one invocation of a code at a time per instance. And the cloud is able to run many, many such instances all at the same time. Now, it gets even more interesting. We realize that the billing model of serverless is per usage. So right now, if I have a blog, it has to sit on a server, and I'm paying on a capacity basis. It means that I'm paying, let's say, $5, $10 a month for Amazon to run it. But if it's running as a Lambda, I'm only paying for when there is an active request going on. And that's really interesting because it has two impacts for that. First of all, if I'm at low capacity, I won. I don't need to pay for the unused capacity. If I'm at high capacity, something even more interesting happens. And it means that I don't need to worry about how am I going to scale myself up. Let's say that a blog post of mine hits a Hacker News, or there is a Twitter storm or something like that. Well, Amazon is going to be the one who is going to be spawning a lot of individual instances in order to handle the load. I would pay for all of those invocations, but it doesn't actually matter from my perspective if I have 1 million requests in a month on one day, or throughout, or 1 hour even, or throughout the entire month. I'm paying for the same amount. So let's look at how it works. And the answer is that mostly magic. I also understand there are some fairy dust involved, but mostly magic. And the basic idea is that there is some sort of an event, a trigger, that cause your code to run. And if you're talking, this trigger is an HTTP request that comes from an API gateway. And then what happens is that it basically takes your, it's going to take your code, all of the content of the request, send it to your code as a single entity, get the value out of that, and send it back to the user. You can also plug this in for, whenever I'm uploading something to blob storage, raise me an event, and I would write an Azure function to handle that. And a lot of the time, you can also do some really nice things around chaining of operations. So what do I mean by that? Let's say that I'm uploading, I need to do license tracking of cars. So I have some equipment in the field that is taking pictures of car and it publishing them to the cloud. Now, I don't want to, I want an optimal solution. So what I can do is the following. I'm uploading the data directly into S3. And after the upload is done, there is going to be a Lambda trigger that is going to run a recognition, which is an AWS service that does computer vision, to recognize whatever there is a red car or whatever that I need to do in the image. And it takes the output of that and write that and send it to another Lambda, which actually then runs some business logic that I have. And the point behind all of that is that I don't need a server to accept and send a request to S3. I don't need a server to wait for recognition to complete the operation. All of that is being handled for me. And it also means that in terms of performance and scalability, I pretty much can check that out of the ballpark. I'm good. Another aspect is that even if I hit some limits, it's going to be sitting in a queue. That's not a bad thing. That means that I'm still able to operate and move things around. I'm very happy about that because, I have a lot of load, then it didn't already hit a server that is being very busy. The cloud infrastructure is going to start spawning additional instances and handle that. And if not, okay, I have some slowdown, but again, I'm not going to crash and burn because of that. Something that is really, really important to understand about the overall concept. It goes like this. You run your code, but you don't have a single instance running. And this can be a huge shift in thinking for many people. Because if I don't have a single instance running, how do I do something like a log? How do I do something like a cache? Everything has to be distributed. For that matter, the average time before your instance is recycled, even if it is busy, is something in the order of 2 to 3 hours. So if you're relying on, I'm going to have a big cache and use that, to optimize myself, well, every 2 hours, you're going to hit the scenario of, I'm completely empty. There is no routing guarantees that you get from serverless. 2 requests from the same user can go to totally different instances. In fact, if they happen concurrently, they are pretty much assured to happen on the same on different instances. So we need to manage persistence around all of that. How are we going to actually keep the data around? How are we going to keep it safe and all those sort of things? This is the role of the database. This is why I'm here. But the last thing I want to say is that instances, you may have multiple instances, but we are still reusing an instance. So we start an instance, start pumping operation into that, and eventually, if there is no load, we will kill it. If there is still load, but it's been running for long enough, we're going to kill it either. I'm assuming that the reason behind that is to make sure that you don't have any long-term bugs or something like that, and it's easy to just kill an instance and not keep it around for months and years, in which case it may run into weird states. Okay, so we don't actually need to do a whole lot of complexity here in order to get Lambda. I'm going to be using the C# examples because I love C#. And here's what happens. I'm going to run these 3 commands. And the first 3 commands, I don't see a reason why you want to see them, is going to generate me this code. And there is some defaults and tooling here, but most of that doesn't matter. I'm now running this. And then I'm going to go here and deploy that to production. Second, I need to. Okay. So what I'm doing right now, I'm publishing this code into the cloud. It's not really that interesting code, but let's look at what we have. And this is what it looks like. This is the publish new post running in the cloud. To be fair, it's not really that interesting. It's just a function in the cloud that has no inputs and no outputs. However, let's go and invoke it. So I'm going to invoke it with this, and let's see what happens. I'm saying, go invoke this function, publish new post. Here is some JSON that I'm going to pass here. Let's hit enter. And it's sticky. Now it's spawning off the new instance. So it may take a little longer to run than what I would wish for. And now it's running, and we got this thing, post 33. So first of all, let's go here. And now you're able to see that I have a new post. I'm going to create another post now. Notice that this is much faster. And here's the other one. So let's go and understand what's going on. Wrong. Here it is. Let's go and understand what's going on. So we have a function, and we call the function handler. What we are ensured by the serverless runtime is that there's going to be a single instance of this function. For each invocation, we'll call this thing. If you're familiar with Java, this is the servlet model, basically. Now, here we are creating the document store and opening a session, and then just saving that. There is absolutely nothing surprising here. It just works, which is a really nice thing because you don't want surprises. You don't want to have, ooh, that's interesting reaction. Something that is super important is that we have to deal with safety. This thing. We are using that to feed to the certificate. Why are we doing that? Well, look here. This is a secured connection. And in RavenDB, secure connection means using external certificates. But I don't want to store that in the Lambda. I don't want to even accept the risk that it's possible someone would check it into code, into a GitHub or do something like that. So we can use the secret manager to do that. And this is the command that we're running. So I want you to create a secret with this name. And I want its content to be the base 64 value of the PFX. And then when we start the application, we're just going and reading that from here. And now I'm done. Here is a really, really, really bad setup. Look at the code and think what's going on here. What you can see is that for each invocation of the function handler, I'm actually going to call create document store, which means I'm going to have a separate document store for each one of them. That's horrible because it means that I have to fetch a certificate from the secret store. I have to renegotiate the connection to RavenDB. I am losing the benefits of caching, all of that. So this is not something that you want to do. This is a bad idea. Don't do that. Instead, use this. This thing, it's a very small change in the code, but it's a very important one because it means that we only initialize that once. And for the lifetime of this Lambda, we're going to keep the document store around. Now, here is an interesting observation. The way that we are built for serverless instances is based on the CPU memory that we require, multiplied the amount of time that we run. So something to be aware of is that people try to always go as low as possible in the tier. And that's valid behavior. But you have to remember that if you're running this in a larger system, then the HTTP cache that RavenDB has by default have more room to operate. And that may actually reduce your latency. A lot of that depends on your actual scenario, what you're doing, etc. But this is something to take into account. Okay. Just a small reminder, RavenDB Cloud has a free instance available, which you can access from Lambdas, like I've just shown you. And in the Lambda, the first million calls per month are free. So you can actually have something that is completely free, both compute and persistence handled for you. Okay, so what we have so far is a very simple system. We have a system that goes and talks to RavenDB from the cloud. Aside from needing to manage a certificate, there is nothing here that is special about RavenDB in any way, shape, or form, which is a good thing, obviously. But what happens if I want RavenDB to call me to do some action? So RavenDB has this notion of subscriptions, which allows you to do all sorts of really interesting things. However, those subscriptions needs to run somewhere. How are we doing that? Let's look. In here, I have a function that responds to operations from RavenDB. In this case, it responds to new post generated, and the way that it responds is by generating an email for that. We've actually seen that in action already. Check those emails. What created this email? The act of creating this. So let's talk about this for a second. I'm going to want to create a new one. And this is all I did. So here's a new one here. And in a few seconds, we're going to see someone here. Why is this the case? Here is the new email. Why is this the case? Let's understand. From the perspective of RavenDB, we did something very simple. We defined an ETL process that goes to RabbitMQ. And it transforms all of the posts into this structure. And we have an existing RabbitMQ instance running in the cloud, which is plugged into this. So the basic idea is that as document goes into RavenDB, we are pushing them into RabbitMQ. But this pushing of things into RabbitMQ isn't done because I have this Lambda that is going to react to those changes. This is the input of the operation going into the actual action itself. And you can see what I'm doing here. I'm accepting the RabbitMQ event. And then I'm saying, give me the first item from, give me the first item from the queue. In this case, I know that I have only one queue. And then I start running over them. I'm converting them into the appropriate JSON format that I want, and then I can do something with it. The key aspect here is that I'm actually able to give you this reaction. You write it to RavenDB, and your code manage that through Lambdas. So that is a really cool feature set. I'm about halfway done on this presentation, and I'm going to move to another topic altogether. Before I do that, do you have any questions, stuff you would like to know about AWS, Lambdas, Cloud, Serverless, those sort of things that I did not cover? If you have any questions, feel free to raise your hand or write it in the chat or something like that. Okay. If there are any questions later, I would be very happy to answer them as well. So one side of serverless is Lambda, Azure Function, those sorts of things. Another side of serverless is something called Cloudflare objects, Cloudflare workers. This is available here. 1 second. And Dennis is asking, does RavenDB support Azure Function input and output binding? Yes. In fact, we are currently working on publishing the documentation for that. And you should be able to get the early access here. I'm sending the link here to answer that. And where is the chat? And that's it. Okay. And Philip K is asking, is this feature equally straightforward on Google Cloud? Pretty much. There's nothing really that interesting in actually managing that. And the feature set is similar, and the way that we behave means that because we are moving through RabbitMQ or Kafka in order to manage that, this is something that is shared across many different clouds. So this is a true cross-cloud platform for how you manage that. Okay, so let's go back to Cloudflare. So this is Cloudflare. They allow me to do a whole bunch of interesting things. The one that I'm most interested in doing, where is the pages? Yes, what the hell? Oh, I did not deploy that. So here I have a worker. It's not really that interesting, a worker. What we have is this database. Let me show you what we have. We have a database here containing all sorts of books. And what I'm going to do now, I'm going to run and select a book to read. Okay, so now I'm running this. In a few seconds, this is going to start. I'm running this as on my own system. And this is going to run, start, all of those sorts of things. And here is test driven. So I want you to understand what's happening here. I'm running, and I started without the URL. So what we did is run this thing, which is give me a random book from the list of items that we have, and go there. And in here, we see something really interesting. We are loading the item. We are doing this interesting change, and now we're good. This is kind of scary, because now I'm updating the number of views that you have here, and I'm just giving you the HTML. I know that you're amazed by my HTML slinging abilities. So, and again, run a book. By the way, yeah, so all sorts of interesting things. Now, if I'm going to look at this one, I'm going to see that here is me. This is the views from Hadera. And you can see that there is one view from there. 1, 2, 3, 4, 5, 6. And I killed it. Why did I kill it? Because I was running too fast. I'm running on a small system here. Where was I? Yes. So now let's go here. Now you can see that I have additional requests. Is this a sync? No, it's not a sync. The error that I actually got does not make sense to me. It says that I did something async without waiting for that, but I don't think that I'm seeing that. Anyway, what you can see here is RavenDB code running inside of a Cloudflare worker. So why is this a big deal? It's a big deal because unlike Lambda or Azure functions, workers don't run in a particular region. They actually run on the edge, which means that Cloudflare is going to run you as close as possible to the customer who is making the request, which means that your latency dropped by a lot. And you typically use that as glue to do something. Oh, I want to make sure that people from Hadera goes to this location, people from Washington go to this location or something like that. But you can actually do fairly sophisticated things here. And the nice thing about it is that because you're running in such a fashion, you're very widely distributed near the user with almost no latency between you and it. So those are the processes that we have to go to actually make this happen. We create a Cloudflare application, we install RavenDB, and now we need to set these two values. We want to have node compact capabilities, node compatibility, which means that we are able to use the standard RavenDB client to manage this. There's been some changes requiring our client in order to support it. We have done that. And now the official release client has full Cloudflare support. More interestingly is that we have this thing. What's going on? Well, if you look at the actual code that we have, you can see that I'm not actually setting the certificate anywhere. What's actually happening is that I'm using something called mutual TLS, and I uploaded my trusted certificate into Cloudflare, and then in the Wrangler configuration, I'm saying, hey, I want you to bind to this name, this certificate identity. So now when my Cloudflare object issue operation to RavenDB, this is being sent as if it was an operation when with this certificate. So the whole idea is that I'm now able to securely access from Cloudflare without needing to go to Secret Manager or how do I distribute something that is sensitive, etc., without really needing to think or worry about that, which makes me very, very happy all around. Okay. So now, when we are running in Cloudflare, this is the absolutely most important line. What happens here? Well, we defined in the Wrangler TOML what is DB cert. And now, in here, we define this. This is being provided for us by the environment. Basically, this is happening because we run this code, because now I have access for this. And then I'm just telling RavenDB, the RavenDB client, hey, this is how I want you to talk to the network. And we bind it to that particular certificate. And now we're done. Now the system is working. Let's look at the books that we can read. It's this thing. And that's awesome. Apparently can do all sorts of interesting things. Now, you will notice something interesting. What do we have here? What is this? This is the idea of the document and the source that it came from. How am I getting that? Well, let's look. this is coming from here. So this is another database that I have available to me. I have the local database and I have the edge database. So far, so good. But then I see this, and this just looks weird. What's going on here? Well, remember that Cloudflare is actually a widely distributed environment. I want to be able to push my code into any location that Cloudflare reach and have it get the right number, the right values from the closest locations. So I'm doing that using this. So I have a create store, and part of the create store is making a request. So what happens here is that I'm actually making 2 requests to different clusters. Just to give some context around that, here are the 2 clusters. Here is one of them, which is running in Ireland. Here is the second that's running in Australia West. So they're kind of far apart, as far apart on the globe as I could make them. But because of the way that I'm setting things up, I'm asking both of them for give me a value. And look at this line, promise any. This will return the first result that I have that completed. So this is actually going to select me the one that is nearest to where I'm actually physically located. So these 12 lines of code do something kind of incredible because they do the appropriate selection of the node without really needing to think or worry about it in any way, shape, or form. Now, so why do I have the local? Let's talk. Okay, this is what I explained with the promise any. And I'm really, really happy with this code because this is so small and smooth, and it does just the right thing that I wanted to do. So now, I can talk to different servers. Great, here is the server. This is S, this is running in Ireland. And FarDev is actually running in Australia. So what am I supposed to do here? I'm going to write, let's say this is ready. Okay, I push this. But I also have this guy. What's going to happen then? The data is now going to be distinct, divergent. And here it is. And let's see what happens now. And now this is still ready. And a few seconds later, this is done. So what we're actually doing here, we're taking advantage on the capabilities of RavenDB. We can set up replication between these nodes that belong to different locations. And even on a high latency system, such as replicating from Ireland to Australia, we're able to operate nicely. The end result from my perspective is that I can make changes that would percolate to the rest of the environment. And then whenever I need to access and read them, I can do that from my local storage at almost no cost. And you do have to be aware of the latency between operations. For example, if you want to say, oh, you have 2 times an hour to make a request to, I don't know, to get financial information. So if I'm able to route my request to different location that sits on different data stores, then it is possible that it will get stale information because you're now running here and the data was modified here. So you won't know that until you're absolutely synchronized. So that's something to be aware of. Now, sometimes I don't want to have just the global state. I want to have local state as well. How does this work? Well, you can actually see it here. This thing comes from the local state. Here's how I define that. It's just a different database. And now we can see how this behaves. Now I'm going to force it to go and talk to, where is it? No, wrong visual. Okay. Okay. Now this runs, it's updated, blah, 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 blah. Now let's see what happens. Now I'm expecting this would take longer amount of time. And apparently we have a promise reject, maybe because of security, which is what I would expect in this case. Let's see. Certificates. Yeah, I still need to add, I'm using the okay. Let's just give it admin access. Cloudflare. And now let's try this. And hopefully now we're going to get a better result. And we're getting a better result. Now we can see this was from Australia. And I got it because, where is the Australian one? Yeah, this is FarDev. And I got it here. Philip K is asking, is this configurable in local databases to be in compliance with different national data localization and privacy rules? Yes, you can do that. So for example, you could say, there is, I'm doing that here somewhere. Here we go. So you can say, okay, here is the city operations. And you have a lot of other things and operations that you want to have. Here is a good one. Is EU country. If this is the case, then I can force it to use the appropriate location, even if this is faster. And at that point, I'm in a better position to be compliant and everything like that. To be fair, the expectation was, oh, I need to be able to do it as quickly as possible, not necessarily about, oh, I need to meet compliance goal, but this is entirely possible to do here. And with that, we have about 4 or 5 minutes more for questions. And the basic idea here is simple. You're able to utilize RavenDB both as a persistent solution for serverless, both in the big clouds, Amazon, Google, and Microsoft, as well as on the edge using Cloudflare workers. You're even able to go the other way around. RavenDB is running, and it will be pushing data that you will then process using Lambda invocations. And with that, I would open the floor for any and all questions that you have. And in the meantime, I want to remind you, you can get started on the RavenDB instances for free. Combine that with the ability to run 1 million free requests, means that you have the ability to start playing without needing to do anything, without any out-of-pocket expenses. And it's a really nice approach for design and operations. And with that, I don't think there are any questions. If there are any afterward, feel free to ask them on the GitHub board. We would love to talk to you. Thank you very much, everyone. Have a great evening.